Hello, welcome to this channel. My name is Enoch. Today we will continue our series on Python, and we'll be looking at list. We'll look at randomization. We'll look at modules and how to create our own module in Python. And let's get right to it. Now, in my previous videos, I have discussed primitive data type, which include data types that have single item. It can be a string, it can be a string. I say name equals Enoch, something like that. I can say num equals 2. That's an integer. When we define float, we talk about boolean like that. They are single they are variables with single item. But let's assume we want to write the name of state in Canada. And we say state 1. We say state 1. We just start numbering it. We just start naming it one after the other. And we say state 2, and we say state 2 is Quebec, and we keep naming it like that. But instead of putting it separate like this, why don't we just put it together in together? I can say state or state in Canada, and I can start naming them. I can put them in a square bracket like that, and I can start naming them one after the other. Ontario, Quebec, and so on and so forth. So that is just an example. Now, so instead of putting them separate, we can actually decide to put them together like this. So there comes a time in your programming that you group items together like that. We call them composite data types, and we have a number of them. One of them is list. And list usually use square bracket, not parentheses, not curly bracket, square bracket like this. And it can take different kind of item. It can take string. These are string inside it. Now you can put number in it. You can put boolean value in it. You can even take non-item. So that's list for you. And so now list usually use list. Let's try to define it. List is an ordered mutable sequence of data, right? So now ordered means that it has a location in the list. It has a location, and we can retrieve it from that location. They follow each other like that. There can be multiple of same. I can have another Ontario, for example, in the list. It doesn't have to be unique. So ordered mutable means that once created, it can still be changed. Once created, it can still be changed. I will show you an example very soon. Once created, it can still be changed. I can say state in Canada, and you use a square bracket, and you can put -1, and I can say equals to mountain like that. Equals to mountain. So if I say okay, print state in Canada like this, you will see that I have changed it. I have changed the last item there. If I print it, you will see that I have changed the last item there. Okay, all right. So you run it like this. You can see that the last item has changed. So you can change it even after you have created it. All right. So that's list for you. Let's go and check documentation, and let's see what we can learn about let's see what we can learn about list, Python list. Python list, let's just check it like that. Python list, just type Python list into Google like that, and let's try to let's go and use the documentation. Okay, this is the documentation, Python documentation. Now open this. Okay, list. Now you can see list, you can see all these things. You can do it on list data types, add some more method. Here are all of the method. List.append, add an item to the end of the list. Okay, so I can say list dot append, and I can put an item there. I can put let's say I put lion there. All right, so let's print it like this, and you will see that this will put it at the end of the as stated. At the end you can see append. All right, that's getting from the documentation. Extend the list by appending all the items from the variable, so from the iterable. So that means we can I can do dot extend. I can do dot extend, and I can add more to this. I can say Monday. I can say 67. I can say false. All these things will be added to this list, right? All these things will be added to this list. So if you go and print it now, you will see that all these things are added to it from the array. Take exactly one argument. 4 has been given. It's supposed to be in a square bracket. So if you run it like this, you will see that everything now joined to the back. Everything joined to the back. Dot extend. Everything joined to the back like that. That's it. So let's go and see more method. Insert. You can insert an item at a given position. So high is the position, and X is the object that you want to insert. If you go to this list, generally, like we say, is ordered. Is an ordered means each item has a particular position, and they can be retrieved from that position. And usually, it starts from 0. It's 0. Start from 0. 0. The last item from the left is 0, 1, 2, 3, 4, 5, like that. And if you are starting from the right, is negative. Negative 1, negative 2, negative 3, negative 4, negative 5, like that. So if I say of 0 like that, and if I say print state of Canada, and I say of 0, you will see that it will, print Ontario. That's the first one. If I change it to 1, it will print something else. It will print Quebec. You can see that. If I change it to 3, you will see that it will change. So 0, 1, 2, 3, and I can say -1. See, it will print the last one here. Ontario, like that. So you can, if I say -3, it will print true, like that. So that's that. And so let's go back to the documentation. So you can remove list.remove, and you put the item. You can pop, say remove the item at a given position in the list, and return it. You can clear, remove all items from the list. You can get an index of a particular object. You can count the number of occurrence of a particular object. You can sort, depending on the key you want to use. You can do a reverse, you can do a copy, and we have example here. They give us an example here. Count the times that apple occur 2 times. you know, index. This one is at index 3, you know. So and they reverse and they print it, append grape to the end, sort, and they sort it and print it. You know, you sorted it out alphabetically, pop, usually pop the last item, you know, and return it. You know, so check through this documentation and familiarize yourself with this list. Using list in a stack, you know, you can check it out like that and just understand it a little bit. There's no big deal, it's just pop that is using there and append. It's just the method that they are using list as a queue. You know, check it out. So append, use append, pop left, you know. So that's just that list comprehension. That's just creating a list from an empty list. You know, list comprehension provide a concise way to create a list. See, first define the empty list, and for x in range, you know, square dot append and square root of each object. So this range is 0 to 9. So 0 raised to power 2 is 0, 1 raised to power 2 is 1, 2 raised to power, you know, like that. So just check through it and practice it. If there is anything you don't understand, you can simply put it in Google. And you may be thinking, are you supposed to cram any of this? You don't need to cram it. Anytime you need it, you can just check it through Google. You know, just check it through Google. Type it in Google. You know, how can I? You can say, how can I add an object to a list in Python, you know, in Python. So you don't need to cram it. You do something like this and you get suggestion, you know, dot append, you know, you see an example, append, you know, so whatever. So insert is giving you another option, insert. So this is the index and this is the object that will be inserted. So depending on where you want to put it, it's just giving you examples. So from there, you can simply go and check append in the documentation. You can go and check insert in the documentation, and you'll be able to see how they are used. You know, just investigate further how they are used. You know, and you'll be able to use. So there's no need to cram anything. This W3 school too is very good. You can check it out. You can just go to list from there. You know, you can go to list from there and you can check everything about list, sort, copy, join, you know, all those things. So that's that about list. Let's go to the next one for today, and that will be our randomization. So what is randomization? Randomization generally means introducing unpredictability into something, you know, or randomness into something. You know, in programming, randomization is often used to pick random numbers, you know, shuffle items, you know, simulate games of chance, you know, like dice, cards, lottery. It's also used to test algorithm with random, you know, data. So in Python, we also have something like that in Python, where you can simply choose a value at random, you know, within a set of items, you know, and what we use in Python is a random module. The random is a module. Now, what is a module? That's what the first thing that comes to mind. A module in Python is just a file. Is a file that contains Python code that you can import and reuse in your program. Say it's a file that contains Python code and that you can import and reuse, you know, in your program. You know, Python, when you install it in your system, comes with a lot of modules, you know, that you can simply use when you are writing your code. And anytime you want to use them, you write the word import and you will give the name of the module. We have math module, for example, math module, and I can use it. I can simply say print math dot square root of square root of 16, right? Square root of 16. I can say something like this, and if I print this, you will see that it will give me 4.0. You can see. So that's math module at work. So there are a lot of module that comes with Python, and you can use them in your code, and anytime you want to use them, you simply use the word import and you give the name of that particular module. In this case, the word is random. So that's the way you will import it into your program. Now you may be saying, okay, can we create our own module? Yes, you can create your own module in Python. And if you want to create your own module, let me show you an example. Okay, I have a file here. Let me just name equals to Enoch. Name equals to Enoch, and I can say is married. Married equals to true, and this is a file. This is a Python code that I'm writing here. So I can go and import this in another file and use it. So I will just say import. Now, what's the name of that file? Demo. You don't need to put the .py. That's demo. That's all. And I can access it from here. I can say print demo .name, right? I can say that. I can say print demo dot is married, right? Is married. Yeah, that's what we use to name it, right? If I run it like this, you will see that it will print nicely. Enoch true. This is the import function, import that is working there, and what we define in this module. So usually when people are writing, when they are doing a project and it involves a lot of code, the file has become so big that they may not be able to manage it again. Then they divide it into smaller bits and they can import it like this, in during their programming. So that's a good use of module. You can divide your code into smaller bits, put it in different file, and you can import them, like your imported module like this. So that's a module for you. All right. Now let's try to know more about the random module. Let's go and check Google, and let's go and check how we can use the random module. Okay, Python random module. All right, Python random module. All right, let's go to documentation and let's see what we can learn about. So it's a built-in Python module, and let's see how we can use it. This module implements pseudo random number generators for various distributions. Let's see an example of how we can use it. Let's go down more. You can check all these things out. Okay, let's start from here. Random.range, say functions for integers. Random. So if you want to get an integer, you can use this random.range, and you give a start point, a stop point, and a step. Or you can just give a stop straight. So start, stop, step. So it returns a randomly selected element from that range. Rand range. So the first thing is to import the module, import random, and you can simply, I can say random integer equals to, and I can say rand range, then I can give a stop, I can give a start. Let's start from 0, and I can give a stop, and I can give a step 3. All right, and I can say print random integer for us, right? Okay, this should be random dot. So that's the way we use it, random dot like that, and you'll be fine. Random dot. So this is the start, stop, and step. All right, if you try to print it, you will see to be generating different numbers for you based on what you define there, 93, 99, 72, 40, so that's the random working there for you. let's go to the next one, and you can see how it is used more. Random dot rand int like this, return a random integer n such that a will be less than or equal to n. That means n will be greater than or equal to a, less than or equal to b, right? So that means it will take two arguments. The first one there will be the lower bound, and the second one there will be the higher bound, random int. So if you go inside, if you let's use this, let's use this, so I can say rand int, and I can give you the starting point and the end point, right? This is the lower bound, this is the higher bound, so it will give us something between this, and we can simply print it out, and it will print us an integer, right? An integer, a whole number. It will be giving us at random. It will be giving us at random. You can see like that. So and those random will be between 1 and 100, 1 and 100 inclusive. So that's that for. So let's move on. Let's go and see some other one. Okay, functions for sequence. Now, if you have a list, if you have a list or some kind of sequence, you can use these to actually do it. Say return a random element from the non-empty sequence, and if the sequence is empty, it will raise an index error. So let's see how we can do that. Random sec equals to random dot choice, and I can simply put a list in it, and I can say work, I can say play, I can say for, I can say none. I can say it like, I can just be putting it like that, and I can say print random of sequence, something like that. And if you print it, it will start giving you, one after the other. To start giving you one after the other. You see, play like that. Play, to give you, to be choosing it at random. So you can see it like that. So that's the random at work. So if you go down more, you can go and check how to choose a floating number, random.shovel, sample. Let's see how to pick a floating number. Yeah, let's look at this one. Random.random, return the next random floating point number in the range of 0.0 less than or equal to x less than or equal to 1.0. That means 1 is not part of it, but 0.0 is part of it. So let's go and check. Let's go and see an example of this. Random.random, and I can say random float equals to random.random, and I can say print random.float, and if you do this, print it, it will start giving you between 0.0 and 1 not inclusive, right? You can see that. So that's random at work for you. And if you want to, you can also use the uniform to return a random floating point number n such that a is less than or equal to n less than or equal to b. You see, this one accepts two arguments, right? So you can just use the uniform like that. I can say uniform, and I can say equals to random. Random. Let me just put float. Then I will say random dot uniform. Then I have to give it. Let me make this one 1, and let me make this one 10. thing like that, and let's say print random float, and see, to pick between 1 and 10 for us, but there will be a floating number. You can see that. So you can easily use this in your program anytime you need it. So that's that about random. Please, you can try to check the documentation more. You don't need to cram any of this. Anytime you need it, just go through Google. Google will give you an idea, then you can investigate further on how it is used. You can even ask ChatGPT, and it will tell you more how to use it. These are some examples. You can check them out. So basically that's that. Let us just go straight to our project for today. Let's go straight to our project for today. And our project for today is it's just a small project. It's a game. We just want to write a program to play the rock paper scissors game. A rock beats scissors by breaking it, paper beat rock by covering it, and scissors beat paper by cutting it, So let's try and see how we can play the game. And the first thing usually, is to just welcome people to your game. You are welcome to play the rock paper scissors game, and once you welcome them like that, then the next thing will be to ask them to make an input. You can say your choice. And to be an input, and the first one there is and you want to ask them a question. Pick an item, and you can say type R for a rock, S for scissors, and P for paper, right? So from there, I can just say I want them to answer in the next line, right? And so now we ask them to pick an item. Type R for rock, S for scissors, P for paper, right? And now computer need to also make a choice, right? So we can say computer choice. Computer choice is random.choice. Then it will be R, then it will be P, then it will be S, right? That's what I'm using, right? And I need to import random, right? Then I will say import random, since we want to use the random module. So we are importing the random module. We are creating a list here because of the random.choice, so it can choose out of the sequence, for computer. And from there, what is the next one? The next one then now is for us to start checking who is right or wrong, and who wins or who lose. And the first thing I would also like to do is to print computer's choice. Can say print computer's choice is can say computer choose, and computer choose. Then I can use the f string, then computer choice. Then let's use the f string. Let's put our f there. All right, so computer choice, computer choose, then computer choice, right? So let's see what is wrong with this. unexpected expression part. Yes, we are supposed to end this with a curly bracket. All right, so this will be fine. No, it's not supposed to be there. It's supposed to be inside this. All right, so that's that. So now we are supposed to, let's start checking now. Let's first check for draw. Let's first check for draw. Check for draw. Let's first check for draw. So it's a draw if your choice is equal to computer's choice, right? So print it's a draw, right? So we can do it like this, and from there, then now we can check for win. You can check for win, right? So you want to check for win, then you use elif, right? Elif, your choice is R, that's rock, and computer choice is P. So we know that rock, and when you have rock and paper, we know that paper will cover rock, but rock will beat scissors anytime. So let's put S there. So if your choice is R and computer's choice is S, then we print that you win. All right, that's the first one. Elif again. If your choice is S, that's scissors, and computer choice is paper, we know scissors will cut the paper, so you also win. Print, you win. So you win. All right, now also let's do another one for if your choice is P, your choice is paper, and computer choice is rock. We know that paper will cover up the rock, right? So we print that you win, right? You win. Okay, paper will cover the rock, so you win. Now let's check for lose. That's all for win, because we only have 3 choices there. So let's check for lose. And I will check. So we can check elif your choice. Leave your choice in, let's do it like that. Let's create a list and let's put them like that. Leave your choice in. So any other one that you pick, this is the sequence that we win. You have pick R, you have pick S, you have pick P, right? So that we don't continue to now do elif one after the other. Let's just put them together. Any other choice will give you a loss, right? Any other choice will give you a loss. And else, now let's check for wrong inputs. Right? Else print wrong input, you lose, right? Wrong inputs, then we say you lose, right? That's it. Wrong input, you lose. So that's that. I leave your choice. Any other choice, you will lose. And wrong input, then. So that's that. Let's try and check it from the top again. Pick an item. All right, so let's play this game and let's see what will happen. You are welcome to play the rock paper scissors game. Pick an item, type R for rock, S for scissors, P for paper, and I pick R, then computer choose P. We know that paper will always cover rock, so I lost, right? I lost. let's pick another one. Let's say I pick S. Computer to pick S. It's a draw, right? It's a draw. Let's play it again. Let's say I pick P. Computer choose S. Okay, I lost because we know that scissors will always cut paper, right? Let me choose again. Let's say I choose P again. Computer choose S again. Yeah, I lost. Why is computer choosing S all the time? Computer choose P now. It's a draw. Okay, it's a draw. So something like that. Just check it out and try it yourself. If you are confused, just check it patiently. Check it patiently. You know, I don't want to repeat myself in this. You lose. So I just put everything together. Any other choice, you will see that it will be a loss. You know, so and wrong input. You know, for else like that. So if you are confused, you can check my previous videos. You know, and I'm sure you will find your answers. And if you cannot find your answer, check ChatGPT, drop me a question and I will reply your question. All right, thank you for watching. I'll see you in the next video. Bye bye.